Hi everyone, thanks for joining and welcome to today's webinar, Why Upgrade Your TAC7 Filter Wheel. Presenting today is Thomas Meeker, a 3D solution architect at X-Rite. I'm Robert Grotans, the Global Technical Marketing Manager, and I'll be moderating today's webinar. Just a few things to go over before I turn it over to Thomas. Due to the number of people that are attending today's webinar, we will keep everyone muted. But if you have any questions, please feel free to use the questions function on the GoToWebinar panel. And we will have some time at the end of this webinar to answer a few questions. Finally, this webinar will be recorded and you'll receive a link so that you can review the webinar at your convenience. So with that, I'll turn it over to Thomas to get things started.
Hello, everybody, and thank you so much, Robert. We're really excited to share this new hardware feature with the TAC7. Along with that also comes some new enhancements within our PANTORA software. And I'm just going to jump right into it and introduce what's new. And thank you, everybody, for joining. There we go. Sorry. So the first thing I want to do is just do a quick overview. So a lot of the people who will be on this webinar today already may have a system and others may not. So I don't want to leave those people out to better understand what we're talking about and give it some context. So with our system, and we call it our total appearance capture system. So that's what TAC stands for. Involved in this ecosystem is the TAC7 material scanner, which you'll see here on the left, our PANTORA software, which is utilized for working with the digital materials as well as driving both the TAC7 and the next one that I'll introduce, which is the virtual light booth. The virtual light booth is used for validating your digital materials, so giving you a closed loop lighting condition with a screen in the background doing real-time rendering, as well as the physical sample and calibrated light booth. And then the fourth part of that, the most important part, is that final digital twin, digital material that you get from scanning your materials, and that is our AXF format, which stands for Appearance Exchange Format. And that is the file that is then used to integrate with our partners. So next, a little more about our AXF. So the AXF is utilized for the communication as well as the visualization of your material. So the goal being to create photorealistic materials to communicate in digital prototypes before you even start working in physical. So that, of course, allows for faster approvals and reduced prototyping and reduce costs overall. So here's what you see inside. I felt it was important to show the hardware of the TAC7 as it is. What you see in here is a structured light projector, which is used in the acquisition of the textures of the materials, similar to how a 3D scanner would work. You've got 4 industrial grade cameras, which are these 4 here. And what you're about to see is that we're going to be putting this new filter wheel in front of one of these cameras. We also use a spectrophotometer, variable linear light scanner for things like color, transition color flop. We have 32 white LED point light sources. 2 of those have now been replaced by UV LED light sources, and I'll be going into that a little bit more momentarily. We have a backlight module, so that allows for the acquisition of transparent materials, and you'll see that it's also going to be helping with new color transparency. And then a rotation stage for the rotation of the material to better understand anisotropy, things like that. And then 8 spectral light sources. So we're already using color filter wheels. bottom here with the motor in front of it, this is showing one of those motors running one of the spectral filter wheels in front of one of the LED light sources. So we're already using it for color acquisition, but are opening up new features and things to measure with a filter wheel in front of the camera. So here is a quick view from inside of that dome that you saw earlier here. So this is just inside of, in front of one of the cameras. Here are the bandwidth filters for the filter wheel. And then we are also using we've replaced 2 of the white LEDs with UV LEDs. So many of you, if you've seen this presentation or other presentations before, have seen this, and I just want to create the context again for what we are doing. So what you're looking at here are, one here is a photo, the other is a rendering of an AXF of that material. And so usually when people are seeing this presentation in person, I quick ask them, so which is the photo and which is the virtual? Well, I'll give you a couple seconds. There you go. So one is using V-Ray as the rendering engine. The other one was done using a Canon 6D digital SLR camera. And so hopefully you got that right, or if you didn't, just shows again the strength of the TAC7. And then, so not only is it important to be able to create reality with your virtual materials, but it's also important that those virtual materials are consistent across different rendering platforms. So in this one, we show V-Ray with Maya, and then another product called Autodesk V-Red, and showing that the consistency between those 2 software programs with one of our materials. So that being said, the other important aspect about AXF is our integration with our rendering partners. So many of you probably saw this slide grow over time. When we introduced the TAC7 4 years ago, we had 3 partners, and now you can see that it's expanded quite, a great deal since then. So of course, we've mentioned that this will be recorded and you'll have access to this, but should you want to ask questions about some of these integrations, we're more than happy to get back to you. All right, so let's talk about the TAC7 filter wheel. So the first thing I'd like to talk about is the hardware. So we saw inside the dome what this looks like. So we have the filter wheel on the left there, and then we also have these 2 new UV LED light sources. And that's what it looks like inside. And now an overview of the features that are inherent to this new hardware upgrade. So the first thing I have here is that we are now able to do more granular, angular color sampling. So what does that mean? We can do better measurements of materials that are more glossy. So of the glossy materials you might come in contact with, the most important of these are metals. So anything that before you tried to do the measurement of that maybe was more mirror-like, you're seeing with this chrome, are going to be able to be measured much better and much more accurately now with the addition of this filter wheel. So if metallics are an important part of your material database, you will see a great improvement with that alone. Another thing, so now we are able to do more granular spectral sampling. So we have always done spectral measurements of color, but due to all of the rendering engines only being able to accept RGB, that is all you've had access to in our software, PANTORA. So I will go into more of how that is utilized inside the software. But for this, what we're really talking about is outside of that visual spectrum, the UV LED addition, to be able to detect fluorescence and other types of materials with optical brighteners, things like that. As I just mentioned, fluorescence. So we can now do the detection of fluorescence, as well as optical brighteners and things like that. And in future, we will also be able to do the visualization of those. At this time, it is strictly the detection, so that you know prior to doing a full measurement that there are UV characteristics or optical brighteners. And the last thing that is part of the feature set for this is the ability to do colored transmission. So the other way we talk about this is in a colored alpha. So before we could do the measurements of things like meshes and be able to understand where light comes through and where it's more opaque. Now we have the ability to do the actual color that's transmitted through that material. And I'll explain that a little bit more in a second. So this is just another sampling of the new features that we have. So a little bit closer up, zoomed in view of these. So we've got the spectral sampling, significant improvement with more mirror-like materials. Here is an instance where you're seeing the detection of fluorescence. So what it does is it gives you this red highlighting that shows you where on the material there is fluorescence, so which is very helpful before you start to do an entire measurement. Colored translucency. So you'll notice the difference. On the left, you're looking at a material that was measured before the filter wheel with transparency, and then the one on the right is the one with color transparency. So you can see a significant difference with the color, how it reacts in the shadows, and then also the transmission of color and the accuracy of that, and the amount of shadow that's created, which is more accurate than just a simple transparency. So let's look at each one of these a little bit deeper. We are keeping this webinar on the shorter side, so I want to make sure I get an opportunity to answer some questions and maybe even get some time in PANTORA as well. So if I speed through this and you have questions later, please feel free to reach out. So we are looking at further spectral sampling. So what that means is that obviously we have this ability to do outside of the visual spectrum and with the UV LEDs and detecting fluorescents or other chemical optical brighteners. And then we also have, oh, I'm missing an image here. I don't know why that is. But the ability to understand metamerism and how that affects our measurement. So, oh, here we go. So this is helping in understanding why formulation and things like that are important, not only to the physical production of materials, but also in the digital measurement and acquisition of materials. You may have come across these before. These are Pantone lighting indicator stickers. They're used for understanding metamerism if there is an issue between the perceived color and the actual color as viewed under different lighting conditions. This specifically is working under the D65 lighting condition. You'll notice here, so RGB and spectral measurements allow for better, the spectral allows for better representation of those colors. So adding this feature to both the measurement and the ability to utilize the spectral workflows inside of PANTORA, our software, is going to be a huge advantage for our customers. And so what you'll see here is, so before we were looking at just the first measurements here, and here we can better understand how these two are different based on the spectral versus the RGB understanding of those materials. So actually spectrally rendering these materials. Now, spectral rendering is only available in certain rendering applications, but the ability to create your materials spectrally is always going to have an advantage over only working within an RGB color space. So we're giving you that advantage now, and then as we hope, and it certainly appears that many rendering engines will of course become spectral and their implementations as well. So the next part is improved high gloss measurements. And I'm just using this example again because this is a great example of how it's been improved. So on the left, you have before the filter wheel, you're getting a lot of extra feedback from its environment, so which is why it's coming out so much darker. Now we're able to see chromes measured in far better fidelity than before. So like I said, if this is an important part of your workflow, you will find great advantage there. Fluorescence detection. So utilizing the new UV LEDs. Again, here's that slide that shows where there's a warning message, as well as it'll show you where those fluorescing chemicals or optical brighteners are. Here are some other examples. So behind here is actually a piece of printer paper that shows that has optical brighteners in it. So you can tell all around here is highlighted in red because the optical brighteners are showing up versus the actual material. But yet you see, okay, there are still a few that are showing some fluorescent fibers, and whether it's material contamination or something other than that. Here are just a few other examples of others that are showing fluorescence. Sometimes materials that you don't even expect having fluorescent characteristics that may still scan okay with the TAC. You now understand that some of these are actually showing certain characteristics, and maybe why maybe the color isn't showing up exactly as expected. Then we used a few highlighters here just to show exactly the difference between how you're able to visualize these right away. This white printer paper, again, using the optical brightening agents, and then the non-fluorescent Munsell chart material for reference gives you the difference between the two before and after. This shows at the different wavelengths. So you've got the 425 to 625 nanometer and reflected light. And then this seatbelt material, which we use, so the color checker does not have any optical brighteners or fluorescence in it, but our seatbelt does. And so this would all show up in our pre-scan with those red materials. So in here you see a couple of different versions of this, but the photo looks far different than our rendering, and that is because of those fluorescent materials. So if we can know going into this render or this measurement that we are already showing fluorescence, that will help you a great deal in understanding if there are any issues. And lastly, what we've added is color transmission. So that image I showed you earlier, we introduced the ability to do translucency last year. So plastic chips that show translucency, things like that. And what's different now is the ability to do color transmission and absorption. So here is like a tortoiseshell material. So what you would get before, if you measured this SVBRDF with transparency, is an alpha that would look something like this. What we're getting now is actually a colored alpha that allows you to do the color transparency. So you are actually getting both of these, and they work together to create the actual effect of what this material is. Again, here's that material again. This was a nylon textile. And you can see the significant difference between color accuracy, opaqueness, as well as the way it is represented on the back of the material. So you can see this doesn't show any color at all when realistically you would see color. And then also the color transmission and the shadowed highlights. Here's just another one. This was a purple textile mesh, then a red nylon textile. So one other thing that is going to be available and is part of the filter wheel, but is also has to do with volumetric materials, is before you could do anything with a polished surface. So this was what was released last year. Now what's coming with this version is actually the ability to do surface roughness. So now if there's any type of diffusion, you're going to see that, as well as any other type of structured surface or the combination of the two. So a structured or a rough surface. We're really excited about that, especially for our automotive customers already out there. And I just want to give a quick preview of what is also going to be coming along with the software release to support the filter wheel, is what we call PANTORA Connect. This is a one slide quick preview. There will be another webinar coming up later this year where we'll be talking more about this, but I did want to just give you a quick preview now. So what PANTORA Connect allows is the ability of some of our other instruments to be used in your workflow with PANTORA. So now we have the ability to either take CXF, our color exchange format data that you may already have created with our benchtops or our handhelds or maybe a MetaView, and use that information to help inform your AXF files or create new AXF files with our other devices. So this is extremely helpful for recoloring. And now, of course, that's going to change the way that we can search and browse by color, is by creating larger libraries. And for some of those industries, the term colorways for some of your materials. Extracting dominant colors, moving closer to a QC workflow, being able to visualize this, of course, in our viewer, and later the ability to fully do QC with appearance data. So the first connectivity will be with some of our devices, and what is so powerful about this is the ability to use spectral information to do color replacement, not just RGB, because spectral is going to be more accurate and what allows you to do quite a bit more in PANTORA. So just finally, if you're interested to learn more, we do have demo locations across the globe. Here are a few of those. And if you're interested to start looking at AXFs, if this is your first time seeing this, we do also offer a free viewer that's available on the X-Rite website. And you can go to xrite.com AXF. So thank you. I know that was a quick preview of what to expect with our new filter wheel upgrade. We're extremely excited. For those of our customers that are interested now, please reach out to your account manager to learn more about purchasing and having me come on site, or if you are over in Europe, Martin Peter, or in Europe, Shirafeng. And we will be very excited to get you all set up. And as long as you can have people into your site, or we'll come there as soon as you can. So thank you again. And just quickly, I want to show you what some of this looks like in PANTORA, and then we'll spend the last 5 minutes taking questions. So one of the things that we discussed is the ability to spectrally perceive or view color inside of our software now. So one of the things here that we've added, and I'm just going to quickly add another blob here. Let's see. There we go. And we'll take that one, just move it out of the way a little bit. So I mentioned our D65 lighting indicator. So right now we're using a D65 lighting condition, and here is the bottom patch of that lighting indicator, and here is the top patch. So these aren't too far off when you are using the D65 lighting, and the ability to actually view these spectrally is something that was not available before. But you'll notice here we've added in the point light condition the ability to do spectral rendering and change that lighting condition. So now as we change this is why we have these lighting indicators, is to better understand how this is perceived in the different lighting conditions and validate those different ones. So now we can see that's what the lighting indicator looks like in your typical, lighting that you have in your office versus what it would look like if you were viewing it in D65. Not only can we do this in the viewer, but we've actually even added it to our material tray. So now we can actually see that those are represented quite differently. And then the other part that I wanted to show you, so working with spectral workflows is an important part of this. The PANTORA Connect, being able to now connect some of our other devices. But also one of the things that we've added in here is now a variant editor. So I'm not going to run this right now, but I'm going to show you an instance of what we've done. If you wanted to, what you could do is take one of a base material, and then you could say transfer the color via luminance split, and then take some of the measurements from one of our other devices, such as the MetaView. And then what you end up with, for those of you that have used PANTORA before, you may be excited to see this. You can now create multiple material trays. So what we did here with the help of my colleague Martin Peter was to actually change a Pantone swatch from one color, and then by swapping color be able to create the other. So what this shows is this new icon here says that it was a measurement through one of our other devices. So this was done with our MetaView device. You're getting the wavelength spectral information and then the ability to change those out. So this the prism here also shows that this is a spectral measurement and not just an RGB. So the addition of this variant editor, not only can you do color replacement, but we can change coding layers, replace a base layer. We can convert it to a uniform representation. So if you wanted a BRDF from an SVBRDF, adding that roughness to the volumetric and transferring surface structure. And one last thing is now inside of our sample materials in PANTORA, we've given you the ability to utilize our the D65 lighting indicator. You have the same features inside of the browser as you do down here. We've also given you some examples of some, these are just clear coat, tinted clear coat measurements. So those could be added to other materials. You'll notice a couple of materials that have already been here, but also a volumetric, a color transparency, as well as our color checker. So I definitely encourage you to check that out as well to get a preview of some of our new features. So I hope you found this helpful. Please reach out if you have any questions, or reach out to your sales and account manager if you're ready to order. Thank you. And Robert, I'm going to pass it back over to you and let me know if you have any questions.
Great. Thank you, Thomas. We do have some questions. We are right up against time, but I do want to get some questions in here. First, before I go to those questions, If you are interested in talking to someone, whether that's a salesperson or to get a demo, feel free to answer this polling question. One question that I saw come in is someone is asking which rendering engines currently support spectral information.
Great question. So unfortunately, there are only two. But the industry seems to be moving in this direction. I'm just going to show this slide. Right now, it's Ocean and Maxwell. But it's worth noting that even though the other rendering engines don't support spectral information, the spectral information is always held in the AXF. So one day when they do support it, that information will always be in the AXF file. So it is future proof, with the hope that many other rendering engines will move that way.
I'll take just one more question. Can you provide more details or explanation on the use of measured UV data?
Sure. So what this is allowing is really for, like I mentioned before, detection, but also the ability to eventually use these materials in a rendering engine. So it's, the main purpose at this point is to give you fair warning that if you were to bring this into a rendering engine now, this would be the reason why it's not being represented correctly. Now, in the future, what it will also be able to help with is, and this is something that we're going to be working on with our rendering partners, is how to take advantage of that added information, that the outside of the visual spectrum UV information. What we'll probably see first is the ability for us to implement this and plug in like V-Ray, just because we actually create that plugin. And then we'll work with our other rendering partners to take advantage of this. There are a number of factors that go into being able to visualize this, lighting situations, things like that, that will be important to communicate with our partners. But for now, it is really about getting that information, being able to look at that information from a spectral response standpoint, but then also in the future be able to actually use it for more visualization purposes. I hope that helps.
Great, thank you. We have a ton of more questions actually coming in, but we are right at time. So what I will do immediately after this webinar is I will export these and send them over to Thomas to see if we can get you some personalized responses. Again, a recording for this webinar will also be sent tomorrow. So with that, we'll end here for today. And I just want to say thanks everyone for joining, and have a great rest of your day.
Thanks everybody. Have a good day.